Hi, thanks for visiting our site. This is a look at the Machinist Journeyman. The Machinist APPrentice 2010 was released. This one will be coming out in 1st of February 2010. The Machinist Journeyman has the more desired advanced features that everyone's looking for. It just took longer to develop, and getting some feedback on the user-friendly layout was very helpful from the apprentice, so I know that I'm on the right path for people who use the Journeyman. Let's just go through a few of the basics here. You've got 5 selections here in the front: milling, turning, math, references, and information. Milling, you'll be coming up here. Let's just go to a regular RPM conversion with diameter and surface feet. We'll say it's a 3/4 inch diameter tool or part, and you want to run 400 surface feet, and you would push calculate, and there's your RPM. Okay, let's go back. You can always drop down the keyboard also at any given time. We'll go back to that menu. In milling, let's go to the calculations on the top are inches per minute. The calculations in this zone right here are inches per revolution, as some people do program in inches per revolution. But let's go to RPM in inches per minute is what we want to find. We know we have a 2-inch cutter. It has 5 flutes. We want to run 450 surface feet, and the feed per tooth is 5 thousandths. And we're going to push calculate, and there's your RPM in inches per minute. Okay, every layout is similar to this, where you're going to enter a number into the field and push calculate, and somewhere on the screen your answers come up. Okay, now another nice thing here is on the ball nose calculation, you're going to find out here, I've got a picture showing you that due to the depth of cut on the radius, you will now get a true cutter diameter. So let's see what happens there. If we took that 2-inch cutter and had 5 flutes, 400 surface feet, feed per tooth of 5 thousandths, but we're going to put a depth of cut of 20 thousandths. Now it's going to also give me an adjusted RPM in inches per minute due to the true diameter. So let's find out what the true diameter is. Instead of calculating 2 inches, it's going to calculate it at 398 thousandths diameter, and that's due to the depth of cut. So with that surface feet and chip load per tooth, here is your new RPM in inches per minute. So it's a chip thinning factor. Now, along with that, you'll see a radial chip thinning factor with a picture of something less than half the diameter engaged, and it's going to ask you for width of cut, and it'll give you adjusted inches per minute. And also with a 45-degree lead cutter, you have a thinner chip, and it's going to give you adjusted inches per minute, and it'll show you the regular inches per minute. Let's just see how much faster that's going to go. We got a 3-inch face mill. Let's say it's got 6 flutes. We're going to run 500 surface feet in the material, and suggested chip load is going to be 5 thousandths per tooth. Okay, what we're doing here is it would have calculated that out at 19.1, but since you're with a 45-degree and it shows that it has a thinner chip here than what the advance of 5 thousandths per tooth, you need to increase your chip load. So from 19.1 as the regular, you're running over 27 inches per minute now. Much more effective, and the tool will actually last longer. Okay, so that's just a little bit of what's going on here. I do have an interesting one here, pretty exciting to put this on, inches per minute. It will actually give you a G-code thread mill program. You type in the information in these 7 fields. I know it's small. I'll work on auto rotating this so this zone is blown up for you, and as you turn the phone sideways, but it'll give you line by line a single pass thread mill program. So that's pretty exciting. Okay, let's go back to the main menu. We'll see what some of the things that are in turning besides your typical RPM and surface feet per minute. We've got helix angle calculations for laydown threading inserts. If we're going to cut a half 13 thread, you type in the major diameter 13